The sun just went out. Not exploded. Not dimmed. Gone 4 seconds ago, and you are still warm. The sky is still blue. Your shadow is still exactly where you left it. Nothing has told anyone yet. It hasn't told the sky. So, the question isn't what happens when the light stops. You already know that one. The question is, what you're going to do with the next 8 minutes. Kevin's using his to queue for coffee. One more thing, before we start. There's something on this planet that isn't going to notice any of this. Not the dark. Not the cold. Not the end of it. I'll introduce you when we get there. Let's be honest about what we just did. You can't take a star out of the universe. Not. It's unlikely. The equations won't have it. Mass and energy don't leave. It's the one rule the universe actually keeps books on. Ask general relativity, what happens if the sun vanishes, and it doesn't say, that would be bad. It says, no. So we're going to do it anyway, because the 8 minutes are worth it. Here's the thing. Nobody tells you about light. It's not fast. It's just faster than everything else. And we've never had anything to compare it to, so we call it instant. The sun is 150 million kilometers away. Light crosses that in 8 minutes and 19 seconds, and that number moves. Our orbit isn't a circle. In January, we're closer, and it's 8 minutes and 11 seconds. In July, we're further out, and it's 8:27. 17 seconds. That's the difference between January and July. That's how much of your life is spent further from the news. So, it's gone. And for 8 minutes and 19 seconds, everything is fine. Not seems fine. Is fine. There is no experiment you can run in that window that comes back wrong. The light is real light. The warmth is real warmth. It left a star that existed when it left. You're not living in an illusion. You're living in a delay. The sun went out 8 minutes ago. You're finding out now. The light runs out. Not a switch, not a fade. The last photons that left a real star arrive, and behind them, there's nothing following. Half the planet is asleep. They are about to miss the most spectacular thing that has ever been in the sky, and they are going to miss it by being unconscious. The other half is standing outside in what has just become, permanently, the outdoors, at night. Kevin gets his coffee. Except, the sky isn't quite empty yet. The moon is lit by the same sun we just lost. So when the light stopped, the moon stopped being lit too. But that has to travel out to it, and then all the way back to you. Which makes the moon the last thing to go. And how long it hangs on depends on where it is. new moon. It's between us and the sun, sitting right on the line. Its darkness arrives at the same instant ours does. No delay at all. Quarter moon, it's off to one side, and you get about a second and a quarter. But a full moon is on the far side of us. The light has to go out to it and come all the way back. Two and a half seconds. 2.5 seconds of a full moon, hanging there, lit by a star that isn't there. It's the last honest thing in the sky. Half the planet is asleep, and the other half is looking at the ground. And here's the thing you'd expect me to say next. That it starts getting cold. It does. Slowly, and much less interestingly than you've been told. And I'll come back to it, because it isn't what kills anything, and it isn't what happens next. What happens next is that the ground lets go. Everything I've said so far is about light. Here's the part that isn't. Gravity isn't instant either. It's not a rope between the Earth and the Sun, pulling all the time. It's a shape. The Sun sits in space-time and makes a dent, and we've been going around the inside of that dent for 4.5 billion years. Take the Sun away, and the dent has to flatten out. And that flattening spreads at exactly one speed. The same speed as the light. Not close to it. The same. We've measured this. In 2017, two neutron stars collided 130 million light-years away, and we caught both things they sent us. The shudder in space-time, and the flash of gamma rays. After 130 million years of traveling, they arrived 1 3/4 seconds apart. That's how we know. Gravity and light run together. Which means, for 8 minutes and 19 seconds, the Earth went around a sun that wasn't there. Held in orbit by the memory of a dent. And then, at the same instant, the light dies. The same instant, not a second later. The orbit lets go. Now, Earth is not flung. Nothing throws it. There's nothing left to throw it. We just stop curving. We've been traveling at nearly 30 kilometers a second this whole time, sideways. And the only reason that was a loop was the sun. Take it away, and 30 kilometers a second is a straight line. We don't fall. We don't spiral. We leave. In a year, we'd be 6 times further from the sun than we are now. Past where Jupiter's orbit used to be relevant to us. Going in a straight line, at the speed we were always going, in the direction we happened to be pointing. Whatever direction we happened to be pointing on a Tuesday. The sun didn't go out everywhere at once. It went out here at 8:19. Everyone else is on their own schedule. Though not the schedule you'd guess. The wave goes outward. But we're watching from here, so what we see is the light going out and then traveling to us. And for a planet on our side of the sun, those two add up to exactly the distance to the sun. When Venus is between us, Venus goes dark in the same second we do. You'd never see it happen. Venus is lost in the glare, showing us its unlit side. But the darkness reaches it and reaches us in the same second, and that is a strange thing to know about a thing you can't watch. Further out, the order holds, and the waiting starts. Jupiter goes about 70 minutes after our sky does. Saturn, about 2 hours and 20. Neptune keeps its light for about 8 hours. A working day, out there, lit by something that stopped existing before breakfast. If they all happen to be lined up on our side of the sun. They won't be. Nothing ever is. And then the solar system is just 4 rocks, 4 giants, and some ice, going in 8 different straight lines, in the dark. Right. The cold. You've been waiting for it, and everyone who tells this story leads with it, and they all quote you the same 2 numbers. How cold it is in a week. How cold in a year. I went looking for where those numbers come from. They don't come from anywhere. Every article quotes the last article. They disagree with each other, and the trail runs out in a magazine. So here's what's actually true, and it's worse. The Earth has its own heat, radioactive decay, and what's left over from being built. It's about 47 trillion watts. It has nothing to do with the sun, and it doesn't stop. That heat sets a floor. Not in a week, not in a year. Eventually. And the floor is minus 237 Celsius. Cold enough that the air stops being air. Nitrogen gives up at 77 degrees above absolute zero, and the sky comes down and lies on the ground as frost. But none of that is what kills you. That's the slow bit. The fast bit already happened, and it happened in the dark, on the first afternoon. Photosynthesis stopped when the light did. Not slowed. Stopped. And every single thing you have ever eaten is standing on top of a plant. You are, right now, 4 or 5 steps up a ladder that is bolted to sunlight, and the entire ladder is now unsupported. We know how this goes, because it's happened. 66 million years ago, something hit Mexico and threw up enough soot and sulfur to dim the sun. It didn't remove it, just dimmed it. That was enough to end the Cretaceous. The grass gets you long before the ice does. Nobody in this story gets to starve slowly enough to freeze first. The oceans freeze from the top. Which sounds like the end, and is actually the one piece of good news in this entire episode. Because ice floats. And a lid of ice is a coat. Under it, the water stays liquid, and the planet's own heat keeps arriving from below. And there is a layer down there where almost nothing has changed at all. Not forever. Earth's a bit too small to keep that up forever. But for longer than anything up here is going to need. Kevin is down there. I'm not going to explain how Kevin got a submersible. Kevin has never once explained himself to me. So, the thing I promised you at the start. What survives? There's an answer everybody reaches for, and I reached for it too. Hydrothermal vents. Cracks in the sea floor, pouring out chemicals and heat, with whole ecosystems around them that never see the sun. Tube worms. Crabs. A food web running on chemistry instead of light. It's in every version of this story. I had it in this script. It's wrong, and it took me 2 days to see why. The chemistry is real. The vent really does supply the fuel, and it really doesn't need sunlight to make it. But those animals breathe, and what they breathe is dissolved oxygen. And effectively all the free oxygen on this planet was put there by photosynthesis. The vent gives them the fuel. The sky gives them the thing that burns it. Take away the sun, and a hydrothermal vent isn't a power source. It's a battery running down. The real answer is 2.8 kilometers underground, and there's only one of it. In a gold mine in South Africa, in water that's been sealed in rock for millions of years, there's a bacterium living at 60 degrees Celsius, in total darkness, with no oxygen at all. It isn't part of an ecosystem. When they sequenced everything in that water, better than 999 parts in 1,000 of it was one organism. And what it eats is the rock going off. Uranium and thorium and potassium in the stone decay. The radiation splits the water around them, and it lives on the pieces. It makes its own food out of dissolved carbon dioxide. It pulls its own nitrogen out of the water. Nothing it eats has ever been anywhere near the sun. The sun went out 8 minutes ago. It hasn't noticed. It was never going to notice. Nothing that has ever happened up here has reached it. None of this is going to happen. Not because it's unlikely, because it's the wrong direction. Stars don't go out. That's not a thing that's available to them. What ours is actually doing is the opposite, and the opposite is worse. It's getting brighter. It always has been. When it started, it was about 30% fainter than it is now, and every century since then, it has put out a little more. That's not a problem you have. It's a problem the planet has, and it has a deadline. A brighter sun means hotter rock. Hotter rock pulls carbon dioxide out of the air faster than volcanoes put it back. And below a certain point, plants can't work at all. Same ladder. Same rung. Nobody has to remove the sun to do it. Then the oceans go, because a hot enough Earth puts its own water into the sky and doesn't get it back. The plants have about 1 billion years. The oceans, maybe 2. You've heard 5 billion. That's a different number, for a different event. Roughly when it runs out of fuel in its core. It doesn't swell up and reach us until about 7.5 billion. The surface has 1 billion. The red giant is somebody else's problem. Which brings us back to the bottom of the ocean. Because, in the real timeline, the one we're actually in, the deep sea isn't the last safe place on Earth. When the oceans boil, they boil from the top, and the bottom is simply the last part to go. The refuge we spent this episode building is one of the things that ends. But the thing in the rock isn't in the ocean. It's in the rock. Eating the rock. Losing the sea doesn't touch it. The rock is still radioactive, and it was never drinking from up here anyway. Everything this episode has been worried about ends. That doesn't. It has been reliable for 4.5 billion years, and it has a few billion more of that in it. You asked what you'd do with the 8 minutes. Wrong question. Wrong question. You've got about 1 billion years, and you're going to spend most of today indoors. Kevin's outside, by the way. First time in weeks. He says the light's nice.